This is Advanced Math, Unit 1, Lesson 8A, 1.8a, Rational Expressions Involving Roots. All right, simplify. Number 1, 4a squared over the square root of a squared plus 1 plus the square root of a squared plus 1. All right, a few things to talk about. First off, this is a fraction over 1. Second, these do not cross-reduce. Kids are always tempted to, oh, they're the same, cross-reduce. You can only cross-reduce when that's a multiplication. If it's an addition or subtraction or even a division, you're not allowed. Division, you would flip first. But addition and subtraction, there's nothing you can do. You cannot to cross-reduce these. Completely different problem. All right, second thing I want to talk about is the square root of a squared plus 1. I'm going to draw this thinking bubble here. Really quick, I've had a few kids ask during class, does this equal x squared plus y squared? The answer to that is no. No, 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 never. You would write this twice and double distribute, which would not come out to be the same. And you can see that with something as simple as this. Are those equal? Order of operation, I would do 5 plus 2 is 7. 7 squared is 49. Is that going to equal... I forgot to put my square there. Is that going to equal 25 plus 4? It is not. Mathematically incorrect to distribute your exponent when there's an addition or subtraction inside. The same thing is true when you're square rooting. If I have x squared plus y squared underneath the square root, kids will often say, oh, they're both perfect squares. It equals x plus y. That is incorrect. It's the same as this one. I cannot, there's a plus sign inside, plus or minus. I cannot take the square roots of individual pieces. Again, I'll give you an example. 25 plus 4 underneath the square root. Does it equal the square root of 25 is 4? The square root of 4 is 2. This is the square root of 29. Does that equal 7? It does not. So just a heads up, remember that you cannot distribute exponents or take the square root of individual pieces when it's a plus or minus inside. All right, so common denominator. My common denominator is the square root of a squared plus 1. And the first one is taken care of. It's going to stay 4a squared. The second one is missing the square root, the denominator, the square root of a squared plus 1, top and bottom. Do you see that it's 1? I need it to be the square root of a squared plus 1. So I multiply top and bottom. The bottom's now the same. Now, when you're multiplying two things that are exactly the same, the radicals undo each other. 1. Root 5 times root 5 is 5. Square root of x times the square root of x is x. Square root of a squared plus 1 times the square root of a squared plus 1 is simply a squared plus 1. And we combine like terms. 4, 5, so that's 5a squared plus 1 over the square root of a squared plus 1. Nothing else we can do. We can't factor, we can't reduce. I do really quick want to show you, some kids will write it this way, and it's totally up to you. A squared plus 1 raised to the 1/2 power. I do want you to think about it because we will be writing it this way eventually. A square root is the same as a 1/2 power. You learned that back in Math 2. And you reviewed it again in Math 3. All right, next one. Number 2, x over the square root of 2 plus x plus 2 plus x raised to the 1/2 power. Okay, first thing we're going to do is make that second one a fraction. And then I'm going to change them to look the same. They are the same. This is 2 plus x, this is 2 plus x, square root and 1/2 power. They're exactly the same. I don't want to use square roots and different one with 1/2 power. So it doesn't matter which one you change. I'm going to change this one to a 1/2 power just to get used to it because we will be using that eventually. All right, now if you wanted to, you could change them like this one up here to be a square root, so it matches that one. And if you did change it, remember these do not cross reduce because there's a plus sign in the middle. All right, common denominator is that right there, 2 plus x raised to the 1/2 power. This first one is already taken care of. It's going to stay x. It already has the denominator. The next one is missing it completely. So if this is the common denominator, I'm going to multiply by 2 plus x raised to the 1/2 over 2 plus x raised to the 1/2. 1 times that becomes the common denominator, so we can now write it as one fraction. Plus, these two have the same base. Now remember, if they have the same base, what do you do with the exponents? X squared times x cubed is x to the 5th. You add the exponents. 1/2 plus 1/2 is 1. So you're simply left with 2 plus x. If you had changed them both to square roots, it would look something like this one. The square root times the square root where the insides are the same. The square roots undo each other. Same concept. 1/2 plus 1/2 is 1. You're left with just 2 plus x. Okay, so this is 1x plus 1x is 2x plus 2 over 2 plus x raised to the 1/2 power. Okay, so let's see if factoring helps. I'm going to take out a 2, leaving behind an x plus 1. And even if I flip this to be x plus 2, you do not have to. These are not the same, so I cannot reduce. So this is my answer. But since factoring does not allow you to reduce, you could have left it this way. So either one of these would be correct. And again, you didn't have to flip it to x plus 2. You could have left it 2 plus x right there. All right, let's try another one. Number 3. Square root of 1 minus m squared. Remember, you cannot take the square root of individual pieces. Plus m squared all over the square root of 1 minus m squared all over 1 minus m squared. First thing I'm going to do is make this a fraction. And also make this a fraction. That always gets people every single time. Please remember, this here is not part of your common denominator because there's a 1 underneath it. Okay, it's a complex fraction, which is different from adding and subtracting fractions. When it's adding or subtracting, we multiply by what's missing to make it the same. When it's a complex fraction, we multiply everything by the same thing and clear, clear, clear. You are not clearing on this side. You're just what's missing, combine like terms, and see if you can factor and reduce. Here, clearing. So we multiply everything by the common denominator, which is right there. So I'm going to multiply everything by the square root of 1 minus m squared. Square root of 1 minus m squared and the square root of 1 minus m squared. All right, here they're the same. The inside, the bases are the same, so the square roots undo each other. So you're simply left with 1 minus m squared. Plus, those two there reduce m squared over, now here, right here, is a part that comes up on the test that you do need to know. Can you see that the 1 minus m squared and the 1 minus m squared are the same? Now, if you left it like this, the square root of 1 minus m squared times 1 minus m squared, you would get it wrong. And I'll show you why. What you're going to end up having to do, let's go ahead and combine these first. The negative m squared and the positive m squared are gone, leaving behind a 1. Now here's why you would get this wrong, because I can rewrite this one right here, 1 minus m squared raised to the 1/2 power. Square root's the same as a 1/2 power. Why do I do that? Because this second one has a power of 1. I don't see it, but I know it's there. And now that the bases are the same, what do you do with the exponents? You add them. when you're multiplying like bases, just like we did on this previous page here. Where was it at? Here it is. The bases were the same, so we did 1/2 plus 1/2 is 1. We're going to do the same thing here, only now we're adding 1/2 plus 1. Think of it like this: x to the first times x to the 1/2. You would add the exponents. 1 plus 1/2 is 3/2, x to the 3/2. So that's what I'm going to do here. 1 over 1 minus m squared is staying, because that's the base. 1/2 plus 1 is 3/2. And that there is your final answer. Get used to this, to recognizing that these two are the same basis, so changing that to the 1/2 power, and then adding the exponents, because that concept is on the test. That is it for this lesson.